All right. So today what we're going to do is look at section 12.A, substitution. Now this is something we've done before, and the book actually calls it substituting with integers or negative numbers, but there's no difference in the process. So it's not a good idea to always have little special rules for every single thing when you have one rule that works all the time for every number, right? So that's what we're going to look at here when we're talking about the substitutions. So I'm just going to remind you of those rules about substitutions, and we're going to talk about some examples of using them and how they work, and then we'll look at some more homework together. All right. So the first thing is, if you're substituting, all that means is to simply replace the variable or variables, because you can have more than one, with the given values. So that's what we're doing, is replacing the variable or variables, there can be more than one, with the given values. But as with anything in mathematics, you've got to stay focused and organized. So we're going to have a series of steps to make sure that we're doing this properly. And then, after we replace them, you're going to see that all you have left is just some math to do. So then we're going to simplify it. And remember, simplify is that all-purpose math word that means do the work. In other words, apply the order of operations and finish it off, right? Get your answer. So, here are our steps. First, you're going to replace or substitute. And what that means is that whatever, so they may say that A is 5 and B is negative 3. So everywhere you see an A, you would put in a 5. Everywhere you see a B, you'd put in negative 3 in that case, right? So you're just going to put the right number in place of their letter. But if you'll remember from when we did this before, and now it's going to be even more important, you must use brackets. Anytime you replace a letter with a number, you must use brackets. If you don't, then you're going to change the operation of the original problem. So things that started out being multiplication are going to turn into addition or subtraction. It's just a nightmare. So you've got to make sure. You also are going to have exponents here. And remember that the base of the exponent will change depending on, because it's the thing that it touches. So if the base is supposed to be a bracket, but you leave the bracket off, then your answer is going to be completely wrong, right? So negative 2 raised to the second power means that you're not using the negative, you're just raising the 2 to the second power. But if you have negative 2 and a bracket raised to the second power, it means the whole bracket raised to the second power, right? So it's going to give you two distinctly different answers. So you've got to make sure to use brackets. Now, there is one exception, and it will be good to know, because you can introduce, especially with the way y'all use just one word for all the different kinds of brackets, you can introduce brackets that make it look confusing. You want to make sure that the brackets that you're introducing are making your life easier, not more difficult. Okay? And if you put in brackets when you have this exception, then it looks kind of cluttery. Now, it's not wrong. Every time, if you put a bracket every time you see a letter, that's perfectly fine. And that's kind of the way I'm going to show you how to do these. I'm going to make you fill it out like a form. The one exception is if the variable is completely by itself, you don't need a bracket. Now, what I mean is that it has no sign, which indicates that it's positive, right? Now, if it has the sign, the plus written there, then you need a bracket. But if it has no sign written there, then you don't, okay? No coefficient, Coefficient means the number in front of the letter. Remember, we're talking about algebraic terms here now. Again, we've talked about them before. So if it said 4x, then 4 is the coefficient, so you must have a bracket. Okay? And finally, no exponents. So it can't have any of those pieces of a term and be the exception. If it has any of them, then you have to use a bracket. Okay? So if it was just plain old x, I don't need a bracket. But if it's 4x, I must have a bracket. If it's negative x, I must have a bracket. If it's x squared, I must have a bracket. So do you see the difference there? You have to have a bracket if it has any other term. All right. So, and then after you do that with the bracket, then what you're going to have is you're just going to have a bunch of brackets and things to get rid of. So the next thing to do is to simplify. And remember, simplify just means to apply the order of operations. So you're just going to go through and look for brackets, look for exponents, look for multiplication and division, and look for any addition or subtraction, which we call combining. All right, so let's look at a couple of examples. Say, for example, we have negative 2x plus 3y minus 2. And they tell us that x is negative 1 and y is negative 2. I'm going to be using lots of negatives here because I want to make sure that you really see what's going on. Now, we're told to evaluate this. Anytime you see the word evaluate, that means substitution. Substitute values. So, if you're going to evaluate something, you can't have any unknowns, in other words. Evaluate means find the value of. Okay, so everywhere that I see an x, I'm going to put in a negative 1. Everywhere I see a y, I'm going to put in a negative 2. But you never replace a variable with a number without putting it in a bracket. So, starting off, here's my first x. So it's going to be negative 2 times, I'm going to put in the negative 1 in place of the x. Don't do any math, just put the numbers in. Plus 3 times my y, and then minus 2 doesn't have a variable in it, and my y in this case is negative 2. All right, now that I've replaced all of the variables with the given values, I'm just going to use the order of operations to complete the problem. And the first thing I look for are brackets, and you know there's going to be brackets because you put them there. So the first bracket starts with this negative 2, starts right there. But this one has a second bracket, and it starts at the positive 3. Remember that the bracket starts with the sign of its coefficient. And sometimes the coefficient is just a sign. So the only thing that's not part of a bracket here is that minus 2. So I'm going to bring it down to the next line, because one of the biggest mistakes that you can make is trying to do too much on one line, or forgetting stuff, concentrating so much on the bracket that you forget the stuff that's not part of a bracket. So get in the habit of bringing them down. This one's not very complicated. Some of them can get really complex. If you don't bring stuff down, you'll forget about it. Now, go back to the first bracket. The first place I look is inside. There's nothing I can do to a negative 1. There's no exponent on the bracket, but there is a coefficient or a multiplier. It's negative 2. Remember, the sign goes with the number. So a negative times a negative becomes a positive. 2 times 1 becomes a 2. So then the bracket is gone because I've used all 3 steps. Okay? Now let's go to the second one. Negative 2 inside. There's nothing I can do inside. There is no exponent on this one, but there is a coefficient of positive 3. Remember, the sign goes with the number. So positive times a negative is a negative, and 3 times 2 is 6. Now I've gotten rid of the brackets, right? We're just doing the order of operations, so I look for exponents, but there are no exponents on any of my numbers. Then I look for multiplication or division, but I don't see any multiplication or division symbols there, so I know that this is all combining or addition or subtraction, so we're just going to combine them. Now, since we're combining, we don't have to go from left to right anymore. We just watch the signs. Some of you might want to combine the two negatives together first. Some of you may just want to go in order. It makes no difference. If you see, if I combine these negatives, bring down the positive 2, a negative 6 minus 2 will combine to make negative 8. And positive 2 and negative 8, the signs are different, so I'll keep the sign of the larger and subtract, which gives me a negative 6. Now notice, if I did it the other way, it would make no difference. Positive 2 minus 6 is negative 4. Bring down your minus 2. The signs are the same, so I keep the sign and add, and I get negative 6. So the same answer no matter what you do. And that's the beauty of working with things as signs. All right, so the beauty of working with signs, or the idea of signs, is that then you can start manipulating things a lot easier and more conveniently. Because some of you would like to use the sign rule that if the signs are the same, keep the sign and add the numbers. You might like to use that first instead of the signs are different, so determining which one has the bigger sign, etc. So many times it's convenient to combine all the positive numbers together and then combine all the negative numbers together and then do the difference at the end. It makes life a little easier and you're less likely to make sign errors. And as long as you think of those things as signs instead of addition or subtraction, you can do that. Okay? Now, so that's one example. I want to do an example where you don't need brackets every time. So what if I have I have x plus 2y to the second power. So I'm going to evaluate this, but the only way I can do that is if I have a value to put in place of x and y. So let's just say that x is equal to negative 2 and y is equal to 4. Okay? Doesn't really matter what numbers you use, but again, this part will always be given to you in the problem, otherwise you can't do this. So the first thing I'm going to do is I'm just going to rewrite it using brackets in place of the letters. But I'm not going to put a bracket in place of the x because notice that the x is all by itself here. There's no sign, there's no coefficient, there's no exponent. This is the only place where you don't have to put a bracket. Now, if it had 3x, now it has a coefficient, I would have to have a bracket. If it had a minus in front of it, or even a plus in front of it, I would have to have a bracket. Okay? But if it's completely by itself, then I don't. So I'm just going to plug in negative 2 in place of the x. Plus 2 times something squared. So all I did was leave a bracket for where my y is going to go. And in this case, y is 4. So inside that bracket, I'll put a 4. So all I did was replace my variables with the values they gave me, making sure to use a bracket where it's necessary. Now, if you wanted to put a bracket around this, fine. If you think that you're going to forget brackets sometimes or make a mistake, then use a bracket every time. It's never wrong because it'll just get cleared in just a second anyway. Because you look inside, you look for an exponent, you look for a coefficient, none of those are there, so there's no reason for the bracket to be there. But if you want to put it, perfectly fine. So now let's go through the order of operations. We're going to do brackets first, and we do have them. And this bracket actually starts way over there with the positive 2. Because that plus is the sign of the 2, so the sign and the number go together, right, to create the coefficient. So the only thing that I'm going to bring down here is a negative 2. Now going back to the bracket, I'm going to look inside. 4 is all by itself, so there's nothing I can do inside. But there is an exponent this time. There's an exponent of 2. So that means 4 times 4, which is going to turn into a 16. If you leave yourself a little space above, if you skip a line, then you allow yourself some working room. Then you can do more things on one line if you allow yourself the room to do it. But if you don't allow yourself the room, be careful. And then finally look for a coefficient. The coefficient is a positive 2. So a positive times a positive is a positive. And 2 times 16 is 32. And then finally, we look for multiplication and division. I don't have any, but I do have some combining to do. So negative 2 plus 32, the signs are different. So I'll keep the sign of the larger and subtract the number. So my completed answer is positive 30. And I don't have to write the plus in front, but it's never wrong, and it might save you some trouble. Okay? And that is all there is to it. Can't get any more difficult than that.